Okay. So I've done some notes to take you through number systems. So this is going to be a lesson where we go through these important notes. Then in the coming lessons, we might be doing some more of numbers or some more involving the calculations where necessary. Otherwise, it will be us looking into the application of these nodes. So number systems is what I'm going to be taking you through. So maybe number one, let us talk about the real numbers and discuss what exactly are the real numbers. Trust me when I say these nodes are intended to summarize all that you need to be aware of regarding number systems. So just in case if you are about to write your test, it could be your exam or preparing for that, just remember that I've got these notes. You can just come back to these notes and revise using this same lesson. So let's see. Okay, let's talk about the real numbers, where real numbers are actually all the numbers we normally work with in mathematics. So all those numbers are called real numbers. So any number that you can just punch on your calculator and you say is equals to, or you punch equal sign and it gives you a number, that's what we are talking about when we say real numbers. So at a later stage, you might find that there is what we call non-real numbers. Maybe those are the ones when you punch on your calculator and you say equal sign, it gives you an error. But the one that does not give you an error and gives you a number, those are the real numbers. Very, very much important, honorable member. And again, please be aware that these real numbers, they can be divided into two main groups. Very, very much important that you are aware that real numbers can be divided into rational numbers and irrational numbers. So I think as we continue, I will therefore separate the rational numbers and the real numbers in terms of the notes so that you are aware what falls under rational numbers, what falls under irrational numbers. So now let's jump on to number 2, whereby we are going to be talking about these two main groups, starting with the rational numbers. So this is what you need to know under rational numbers. So a rational number, it is any number that can be written as a fraction. So this statement which says A over a B, whereby B must not be equals to 0. It's simply to say a rational number is any number that can be written as a fraction. For example, whatever letter or number over whatever letter or number. But most importantly, your denominator must never be equals to 0. So your denominator must never be equals to 0, because the moment you say whatever a number divided by a denominator which is 0, it might give you an error on your calculator. So just as an example, let's take our calculator and say 2 over 0. So can you see it gives you maths error, undefined. So that means in this way, we can therefore make a conclusion to say that is not a real number. That's why I was saying sometimes you might find that there's what we call a non-real number. And it should be that one that gives you an error. Okay, so I think that part is clear regarding why they had to mention that and say A over B, it's a fraction, whereby the B being that number at the bottom must not be equals to 0. So I've done some examples there that you can look into. If you punch 1 over 2 on your calculator, it is a fraction and it will give you that 1 over 2. Let's say, what about 3 over 4? Yes, you see, it gives you 3 over 4 on your calculator. When you say negative 5 over 2, yes, it gives you a fraction. So even 6. Why? Because 6, it is still the same as 6 over 1. It is considered to be a rational number, even though it doesn't look like it's a fraction, but you just know that there is that invisible 1, where if you have 7, it is still the same as 7 over 1. It doesn't matter if you have 100, it's still the same as over 1. So that is why it also falls under rational numbers. Okay, so something again that you need to be aware of is that a rational number includes, very much important that you are aware of this important information to say a rational number includes the integers, whole numbers, and natural numbers. What are these things? What exactly are these three things? Okay, so maybe let's have a look at what is meant by an integer. Remember, all these fall under rational numbers. So what is an integer? So an integer is a whole number and it's negative. So that means when you talk about integers, these are the whole numbers and they are negatives. Meaning, starting from all the negative numbers, including 0, and continuing in the positive of those same numbers. Very, very much important that you are aware that when we talk about the integers, it is those numbers where we start from the negative whole numbers and then we continue until the positive whole numbers. Very, very much. But you might be wondering to say, okay, if here they are talking about whole numbers and they are negative, what exactly is a whole number? So you just need to know that whole numbers, they start from 0. So this number starting from 0, continuing in that direction, these are the whole numbers starting from 0. And then when it comes to natural numbers, these are the numbers where we count starting from 1. So example, it would be from 1, 2, 3, 4, 5, continuing in that direction up to infinity. So those are what we call the natural numbers. So now this explanation to say integers are whole numbers and they are negatives. It should therefore make sense to say starting from 0 in that direction together with their negatives in that direction. Those are the integers. I think it is clear in terms of what are the integers, what are the whole numbers, what are the natural numbers. So whole numbers starting from 0, natural numbers starting from 1. Okay, so now let's jump on to the irrational numbers because we are completely done discussing rational numbers. So I think when it comes to irrational numbers, not that much complicated. It's for you to just be aware that, okay, irrational numbers, here we talk about an irrational number which cannot be written as a fraction. So that is an irrational number. So it will be the decimal form never ends and never repeat. So that means an irrational number, definitely, you can't say, for example, 1 over 2, and when you press equals on a calculator, then it gives you that 1 over 2. No, it will give you a very long decimal when you press it, and that decimal, it never ends and it doesn't repeat, meaning you can't have it, for example, as maybe 0,24242424. Nope, you'll find something like 0.17393 maybe 98, and so on. So that's what they mean when they say it never ends, and again, it never repeats. There's this part of saying it never ends. You can't find it as maybe 2,374. No. On your calculator, you will see it will just be that long number, and then it will have those three dots to show that, okay, it continues up to infinity. It does not end. Okay, then it's fine. So examples would be if you punch on your calculator square root of 2. Let's see, I think we get something there. Square root of 2. Then you convert it to a decimal. It gives you 1,414,213,562. Yes, can you see? It is that long number. It doesn't end and it also doesn't repeat. And you can't have it as a fraction on your calculator. And then even if you punch square root of 5, and also if you punch pi on your calculator, it gives you that infinite number which never repeats. Hope that part makes sense. Okay, let me just quickly verify something. Oh yes, my screen is sharing, and again, I am not muted. Okay, then it's fine. So now let's talk about some important terms under number systems. These are very much important because you definitely need to be aware of what are the important terms. So some of the terms that we are going to be talking about include factor. What is a factor? So a factor, it is that number that divides another number exactly with no remainder. An example would be, what is it? Factors of 20. Name. When we talk about factors of 20, it is 1, probably because when you say 20 divided by 1, it gives you a number without a remainder. So it can be, for example, 2 comma something, or 2.5, or 2.25, and something of that nature. If you say 20 divided by 2, it gives you just one number, even with a 4, a 5, a 10, and even with a 20. So that's what we mean when we say it is that number that divides another number exactly with no remainder. So that is what we call a factor. Okay, so here we are now going to be looking at a multiple. What is a multiple? So multiple, those are the numbers obtained by multiplying a number by a natural numbers. An example would be multiples of 5. So multiples of 5, definitely 5, 10, 15, 20, and 25. I think this one is a straightforward definition and an example. So now, what is a prime number? Yes, what is a prime number? So a prime number, it should be a number with exactly 2 factors, and those factors are 1 and itself. Those should be the prime number. So here are examples. You see 2. You can only divide 2 by 1 and itself. And then 3, you can only divide it by 1 and itself. Even 5, you can only divide it by 1 and itself, meaning you can divide 5 by 1 and also by 5. Same with 7, same with 11. Those are the examples. Name. So a prime number is a number with exactly 2 factors, being 1 and itself. Let's see, now we talk about composite number. What is a composite number? So a composite number, it is a number with more than 2 factors. a number with more than 2 factors. Very much important, that part. That is a composite number. An example would be 8. So 8 has got 1 that goes into it. It has got 2 that goes into it. It has got 4 that goes into it, and also 8 that goes into it. So unlike a prime number, which has only 2 factors, but a composite number, it is a number that has 2 or more factors. In other words, more than 2 factors. Not necessarily 2 or more, but more than, because if I'm saying 2, it means it falls under a prime number. But the correct way of saying it is to say more than 2 factors. Yes, more than 2 factors. So 3 and above. Then when we talk about a universal number, so a universal number, it is the number one, let's see, the number one, or the number one is neither prime nor composite. Okay, so this number 1, it is none of this. It is not a prime and it is not a composite. And that we refer to it as a universal number. Just in case you come across that and you wonder what is a universal number, then you know it is explained in these notes. So a square number, okay, a square number, it should be a number multiplied by itself. An example would be 4 times 4, and it gives you that. Okay, so that is a square number. So that means 16, it is a square number because it is a number multiplied by itself, which gives you that. Okay, then it's fine. I think to add on to what I've explained up to this point, very quickly, let's now talk about a prime factor, not prime factor, but prime factorization, where you just need to be aware that every composite number, every composite number can be written as a product of prime numbers. So can you see, now we are making use of those words that we defined. So we will do some more examples probably on a different lesson where we talk about all of this in detail. But here we are having an example where they say 20, it is actually equals to 4 multiplied by 5. That is equals to 20. And then we expand on that 4, where we are going to therefore say that 4, it is the same as 2 times 2, and we also have that 5. So you might find that this, it's what they are talking about there, where they say every composite number can be written as a product of prime numbers. So if it confuses you, you will therefore say, what is a composite number? A composite number, it is that number with more than 2 factors. What is that number? It is 4, because inside 4, 1 goes, 2 goes, and also 4 goes. So can you see, you've got 3 numbers or more than 2 numbers that goes into that 4. So that 4, it is therefore a composite number. But we don't want to write it as this format where you have a composite number and then you also have something like a prime number being 5. So that means in this case, 4, it is a composite number, and then 5, it is a prime number. So we break down this composite number into a prime number, a prime number, and a prime number. So that's what they mean when they say every composite number can be written as a product of prime numbers. So it's like we want to break it down into prime numbers and not a combination of prime and composite numbers. Very much important, honorable members. So can you see these two very much important? We will look into those maybe at a later stage or as we continue with upcoming lessons. So here they are talking about methods to find prime factors. Yes. So those methods can include the factor tree method, very much important. The factor tree method, where you break the number into factors until only prime numbers remain. So here, it is an example of 24, whereby 24, it is the same as 2 multiplied by 2 times 2 times 2. So can you see these 2, 2, 2, and also 3? These are the prime numbers because it is only one and itself that can go into that number. So another method of finding a prime number, it is the ladder method, whereby repeatedly dividing the smallest prime number until you reach 1. We will also look into these in one of the upcoming lessons so that you can be exposed to these two methods to find prime factors. So in other words, it's more like breaking down a composite number until you remain with a prime number, something of that nature. Honorable member or the member who is honorable. Maybe when you look at that 4, because 4 can be further broken down into 2 times 2. Can you see? And then when it comes to 8, you'll realize that 8 is the same as what? 4 multiplied by 2. So that means it should be the same as you break down this composite number again into 2 times 2, and then you still have that other 2 there. So the whole of this, it ends up being the prime numbers, which takes you back to 8. Very, very much important that you do not miss the next lesson when it's available. Okay, so now as I conclude, so to summarize, real numbers include rational numbers and irrational numbers. Remember, and then when it comes to rational numbers, the rational numbers include natural numbers, whole numbers, integers, and fractions. Very, very much important on that part. And then important, and let's see. So important concepts include factors, multiples, prime numbers, composite numbers, square numbers, and prime factorization. So I think I've covered all that you need to be aware of regarding an introduction to number systems. Very much important, honorable member, that you take note of these notes. I think I will leave it here for now.